Hello, I hope you are doing well. I am doing great. Thanks for asking. So, in this video, we'll talk about coordinates and the straight line. It's like a high school topic, I think. The way I have structured it is we'll first go through the theory. It will be quick, and then we'll implement what we have learned using the C programming language. Yes, not R. Today we are doing C. Okay, so let's get to it. Let me switch over to where I have my notes. So, coordinates and the straight line. Let's start with with an empty Cartesian plane, right? So we have our x-axis, we have the y-axis, and then we have the origin, the point 0, 0. A point in the Cartesian plane has an x-coordinate and a y-coordinate. That is what defines a point. So let's add a point P, this one right here, and it's an arbitrary point. So we are going to say that P has the coordinates 2, 7. So the x coordinate is 2 and the y coordinate is 7. Then let's add another point Q, which is -5, -3. So the x coordinate for Q is -5, the y coordinate is 5. And then let's join the 2 points using a line. So we said that a point is defined by its x and y coordinate. On the other hand, now a line is defined by any connection of 2 points. So this line is it's our focus, and we need to determine a few things about a given line. The first one being the length. How long is it from Q to P? What is the distance from point Q to point P, right? And how do you calculate the length of a line? You take the difference between the x values, then you square it, and then you add the difference between the y values, and then you square that, and you find the square root of that summation. So basically we are doing x1 minus x2 squared plus y1 minus y2 squared, and then we are finding the square root of all that. So for example, if we were to calculate the length of the line QP, so in our case, we are going to say that the length of QP this is going to be the square root. It's a big square root here. And then we are saying x1 minus x2. So x1 is -5 minus the value of x2, which is 2, basically the difference between the x values. Then we square that, then plus y1 is -3, then minus y2, which is 7, then we square that. So the difference between the x values squared plus the difference between the y values squared, then the square root. So what is this giving us? So -5 minus -2, that's going to give us -7 squared, and then plus -3 minus 7 will give us -10 squared, and then we find the square root of that. So when you square a negative number, it's obviously going to be a positive. So -7 squared, that's going to give us 49. And then plus, then we have -10 squared, and that is going to give us 100. And then you're finding the square root of this. So 49 plus 100, that is 149. So the length of this line is going to be root 149. So that is how you find the length of a line. Now, the length was our first point. That is the first thing we need to learn about a line. The next thing that we need to know about a line is its midpoint. We want to find the coordinates of the point M, this one right here. So M is exactly at the center of Q and P. What are the coordinates of M? to get the coordinates of M, it's basically finding the average of the X and the Y values. So the X coordinate will be X1 plus X2 all over 2. And then the Y coordinate of M is going to be Y1 plus Y2, and that is all over 2. So it's like taking the average of the X values and then the average of the Y values. So in our case here, to find the value of M, the midpoint here is going to be, we take x1, which is -5, plus x2, which is 2, then we divide all that by 2, and then we take y1, which is -3, plus y2, which is 7, and then we divide all that by 2. So this is -5 plus 2 will give you -3 over 2, and then -3 plus 7 will give you 4 over 2. So this means that the point M is -1.5 and 2. So these are the coordinates of M in our case. So -1.5 and 2. Okay, so that is it about the midpoint. Now, let's move on to the next point, which is the gradient. So how fast is this line rising or falling, right? And many people will tell you that the gradient is the rise, which is the change in y, divided by the run, which is the change in x, right? So to calculate the change in y, we do y1 minus y2. I mean, it's just the change in the y values, right? So y1 minus y2, and then change in x is going to be x1 minus x2. So in our case, to calculate the gradient of QP, so let's say the gradient of QP in our case will be y1 minus y2. So y1 is -3 minus y2, which is 7, all over x1 minus x2. So x1 is -5 minus x2, which is 2. So what does this give us? -3 minus 7 will give us -10 over -5 minus 2 will give us -7. So the gradient of QP is 10 over 7. So that's the gradient of the line in our case. So that's it about the gradient. Then let's move on to the next important point. The next thing we want to know is, if I give you two lines, QP and MN, with arbitrary coordinates, can you tell whether these two lines are parallel to each other, right? Parallel lines never meet. Like, no matter how much you extend them in the Cartesian plane, they are never going to meet because they are parallel. Mathematically, we say that a line QP is parallel to MN if and only if the gradient of QP is equals to the gradient of MN. So any two parallel lines are going to have the same gradient. So just hold on to that. Then another concept that we need to explore is that of perpendicular lines. Now, for perpendicular lines, they are obviously intersecting. They are obviously intersecting. Just a second. Here we go. So they obviously intersecting here. And at the point of their intersection, they make a right angle. So we say those lines are perpendicular to each other. And mathematically, we say that a line QP is perpendicular to MN if and only if the gradient of QP multiplied by the gradient of MN is equals to -1. So basically, if the product of the gradients of the two lines is -1, then they are perpendicular to each other. So let's take a look at some simple questions for the parallel and perpendicular cases. So here we are told, find if AB is parallel or perpendicular to PQ in the following cases. So we are first given the case of the point A is 1, 4, the point B is 6, 6. So the line we're looking at there is AB. And then the point P is 2, negative 1. And then the point Q is 12 and 3. So that line is PQ. So we need to check if the two lines are parallel or perpendicular. So let's start by finding the gradient of AB. So we'll write here the gradient of AB will be the change in y over the change in x. And this, let me just label them. So we are going to say this is x1, this is x2, this is, let me use another color for that. This is y1 and this is y2. So the change, the gradient is the change in y over the change in x. So the change in y will be y1 minus y2. So we just do 4 minus 6 over the change in x, which is 1 x1 minus x2, which is 6. So in this case, the gradient of AB will be 4 minus 6 will give you negative 2 over 1 minus 6 will give you negative 5. So the gradient of AB in this case is 2 over 5. Now, let's check the gradient of PQ. The gradient of PQ, let's add some labels. So we have, this is x1, this is x2, and then this is y1, and this is y2. So the gradient of PQ will be the change in y. So we do y1 minus y2, negative 1 minus 3 over the change in x, x1 minus x2. So that's going to be 2 minus 12. So in this case, negative 1 minus 3 will give you negative 4 over 2 minus 12 will give you negative 10, right? So by negative 2, we are going to have, that's 2. By negative 2, we are going to have 5. So the gradient of PQ is 2 over 5. So the gradient of AB was 2 over 5 and the gradient of PQ was 2 over 5. So for this first case of A, they are parallel. So let's just write here. The two lines are parallel. Sorry. Then let's check for part B. So we do the same thing. So again, we are going to find the gradient of AB, and that is going to be the change in y over the change in x. So x1, y1, x2, y2. So the change in y will be negative 1 y1 minus y2, which is 4, over the change in x, x1 minus x2, and that's going to be negative 1 minus 0. So negative 1 minus 4 will give us negative 5 over negative 1 minus 0 will be negative 1, and so the gradient of AB in this case is 5. Then the gradient of PQ will be, again, we have, this is x1, this is x2, and then this is y1, this is y2. So the gradient of PQ will be the change in y, which is y1 minus y2, so that's going to be 3 minus 1 over the change in x, which is x1 minus x2, and that's going to be negative 4 minus 6. So 3 minus 1 will give us 2 all over negative 4 minus 6 will give us negative 10. And then by 2, this is 1. By 2 here, we have negative 5. So this is the same as negative 1 over 5. And then if we take the gradient of AB multiplied by the gradient of PQ, so we just write the gradient of AB times the gradient of PQ. This is going to give us 5 times negative 1 over 5, which is negative 1, since by 5, 1, by 5, 1. So when the product of the gradients of the two lines is negative 1, then it means that the two lines are perpendicular to each other. So in this second case, the two lines are perpendicular. Then let's take a look at the final case here. So we have again AB PQ. So let's start with the gradient of AB. Change in y over change in x. I think by now you get the drill. So let me label. It's just a habit. So x1, x2, and then let's have y1 and y2. So change in y will be y1 minus y2, and that is 3 minus 2 over change in x, and that's going to be x1, 0 minus x2, 7. So 3 minus 2 will give you 1 over 0 minus 7 will be negative 7. Wait, why did I say 0 minus 7? Oh yeah, the change in the x. Okay, sure. So this is going to be negative 1 over 7. And then let's take a look at the gradient of PQ. So the gradient of PQ again, change in y over change in x, and the change in y is, let's label this. So this is y1, this is y2, and then this is x1, this is x2. So change in y will be y1, which is negative 1, minus y2, which is negative 2, all over change in x, which is 6, x1 minus x2, which is negative 1. So negative 1 minus minus 2 is the same as negative 1 plus 2, all over 6 minus minus 1 is the same as 6 plus 1. So this becomes negative 1 plus 2 will be 1 over 6 plus 1 will be 7. I hope I got this right. 3 minus 2, that's going to be 1, and 0 minus 7 will be, so negative 1 out of 7. And then this is negative 1 minus minus 2. So that's negative 1 plus 2. That's just 1. And then this is 6 minus minus 1, which is 6 plus 1. So 7. Anyway, so okay, I think this is fine. So the gradient of AB is negative 1 out of 7, and the gradient of PQ is 1 out of 7. So obviously they are not parallel since the gradients are not equal, but are they perpendicular? So if we do the gradient of AB and then we multiply it by the gradient of PQ, what do we get? So this is going to be negative 1 out of 7 multiplied by 1 out of 7, and this is going to give us negative 1 out of 49. So in this case, for AB and PQ, they are neither parallel nor perpendicular. So for this third case, neither parallel nor perpendicular, since the gradients are not equal and the product of the gradients is not negative 1. Okay, so that's it about the theory. Let's now turn back to the terminal and do some implementation. So let me move things around here a bit. Okay, so we are now in the terminal, and on the left, uh, we have a to-do list. So just a couple of things. The first thing is we need a way to define a point, obviously, and then we'll need a way to define a line. And then for a line, we need to find the length, the midpoint of that line, then a way to calculate the gradient for the line. And then when given two lines, we need to check whether they are parallel or perpendicular to each other. So basically these are our tasks. And then I'll be running the code on the right side. So let me create main.c. Let's start by including stdio. I'm probably going to do a lot of printing. And then let's define the main entry point for this program. So we'll say int main. So main is a function and it's going to return an integer. Then currently it's not taking any arguments, so we'll just go with void. And at the end of the day, I want main to return 0. And then for a start, let's just print hello world. So printf hello world. Then let's try to run this. So actually to run it, I'm using a makefile. So here's my makefile. So at the very top, I'm saying I want to use the GCC compiler, and then I provide it with a couple of flags. So basically these are all just warnings. So I think this one means give me all the warnings or something. Not sure about that. But we add some extra warnings, and then this last one, I'm pretty sure it's for ensuring that any warning that I have in my program is automatically, like, it's an error, not just a warning. So it's automatically upgraded to an error. And then this, we have a task here called main, which depends on main.c. So that's the entry point for our program. So when main.c changes, then we also want to rerun whatever this main task has. And this main task, it's just taking the compiler we set, GCC, passing in the flags here. And then we are saying, after compiling, I want you to output the binary into a file named main, and we are compiling main.c. And then here I have another task called run, which depends on main. So we are saying if anything changed on the task in main, I want you to rerun main before running before running this current line 7. And then it just runs the executable. And finally we have a task for cleaning, which basically removes the main binary. So now that we already had a hello world program, let's try compiling it. So I'll just do make run, and there we go. So we have a hello world program. So let's go back to the to-do list. Sorry. Let's go back here. So the first thing is we need a way to define a point. Remember, a point has an x and a y coordinate. That is what defines a point in the Cartesian system. So since it's some form of data, we are going to make it to be abstract. So we are going to say, we are going to define abstract. So type definition, it's going to be abstract, and we are going to call it point. And then a point has an x coordinate, so we'll just use double for that. I mean, because it can be something like x.2, 2.2, 3.5, etc, etc. So we'll just use a double for that. So we'll say double, and that is the x coordinate, and then double, which is the y coordinate. So that's a point. And then the next thing was we find a way to define a line. So a line is defined by 2 points. So again, let's use abstract. So we are going to define abstract called line. And a line is made up of the first point and the second point. In our case, let's call the first point A and the second point B. So A is a point. So we are going to say point A and then point B. So a line is defined by point A and point B. Okay, so far so good. Now we need to find the length of a line, right? So we come here and then we are going to say, finding the length, we are going to return a double and then we're just going to call it line length. Yeah, doesn't hurt. Let's just call it line length. And line length is going to take in a line. So we take in a line and we can actually just take a reference to the line. So we are going to say line star and we are going to call it line in small caps. And now what happens? So, how do you calculate the length of a line? To calculate the length of a line, you take the difference between the x coordinates, then you add the difference, oh, you square, then you add that to the difference between the y coordinate squared and then the square root, right? That's what we saw earlier. So let's start with the y difference. So the y difference here, we're just going to have it as a double, and then we are saying this is going to be, yeah, let's just do from the line. I want you to get me point A, and then from point A, I want you to get me the y coordinate. Did I get that? Yeah, probably I got it right. We are about to find out. So we take the line, and then since it's a pointer, so we have to use the the arrow thing. So it's accessing the value of the real value of, okay, what am I saying? It's just saying, get me the value that this pointer points to, right? It's the same as doing something of this sort. It's the same as doing double y diff, and then we are saying we dereference it and then we do dot a dot y. But I think I've seen most people just do line and then you access the property a, or rather the value of a, and then a is a point. So a point has a y coordinate. So there's that. And then we're going to do line dot, not dot, the arrow, and then we access point B, then we access the y value of point B. Then we do the same for the x difference. So we're going to say line, we are going to access point B dot, nope, it's supposed to still be point A. We access the value of x minus line, we're going to access point B and then dot x. So now we have the y difference and we have the x difference. So we need to square both of them. So we are going to say y diff will be y diff times y diff, right? Yeah, I think that looks all right. So the y difference will be the y difference times, let me just write it in full. So the y difference will be the y difference times the y difference, and then the x difference, it's going to be the same thing, the x difference times the x difference. So we basically just squared both of them, and then we are going to add this. So we are going to say, yeah, we can just use out. I'm thinking, let's just go with a double. So double, let's call it out. So we are saying we take the difference between the y plus the difference between the x. We've already squared them. And then we now need to find the square root of these ones. So I think I can just use math.h. So I'll do sqrt of the summation, and then we are going to return out. And since we have done that, we need to include math.h. Trying to think. Yeah, that looks fine, except that now when compiling, I need to include this math library, right? Let me check something like man sqrt. So let's see. Mhm. The math library libm. So we need to include it in our make file. So go to the make file, and then just after the main.c, so it needs to be the last one included. So we are going to say -lm. Actually, let's try compiling without the -lm, and then you're going to see what happens. So we have that, and then let's try to create a line. So I'm going to call it line PQ, right? So line PQ will be equal to, it's obviously a struct, sorry, and this struct is made up of points. So we say we have point A, and then we have point B. So point A is made up of, actually can just have dot A to indicate that it's point A, then that is point B. So point A is made up of the coordinates. So we have the X and the Y coordinates. Let me try and see what were the coordinates for P and Q in our case. So I'll just take a look. Okay, so in our case, point P was 2, 7. So this is going to be dot X will be 2. And dot Y will be 7. And then for point Q, we had -5 and -3. Okay, so that's the line. Yeah, that looks good. That looks good. Okay, so we have that line. Now let's try calculating the length of the line. So we are going to say, let's just have it as pqlen. So pqlen, and we're saying this is going to be a double. So pqlen will be line length, and then we pass in pq. So we pass in a reference to pq. So and pq, the and sign, and then rather the ampersand, and then pq. And then printf pqlen will be, so it's a double, so let's just give it to 4 decimal places and print an empty line, and then pass in pqlen. Okay, so let's run this. So it should fail because we haven't included the -lm at the end. So let's try make run. Yeah, so we have an undefined reference to sqrt. So going back to the make file, let's have the -lm, then try to recompile. And there we go. So our line has a length of 12.2066 units. Okay, so far so good. Now, let's move on to the next thing in our to-do list. So we are done with this. Now, actually we already defined a point. We already defined a line. Then we have now found the length of a line. The next thing is the midpoint of a line. So the midpoint of a line is supposed to return another point, right? Since the midpoint has coordinates x and y. So we expect this function to return a point, and we are saying this is, let's just call it line midpoint. Yeah, I'll just call it line midpoint, and then it takes a reference to a line. And how do you get the midpoint? It is like averaging the x coordinates and then the y coordinates. So let's start with the sum of the y coordinates. So we're going to say double and we are going to call it y sum. And this is going to be, we take our line, we access the real value of a, and then give me the y coordinate. And then we're going to add the same line, access the real value of b, then give me the y coordinate. So that's going to give me the sum of the y values. Then we do the same for x. So we take line, I want you to access a, but this time give me x, and then plus the same line, I want you to access b, and then this time give me x. And now we have the sum. So we are supposed to get like an average, basically dividing the sum by 2. So we can just say here y sum will be y sum divided by 2. But why would I do that? Why not just take all this, wrap it in brackets, and divide by 2? Then do the same for this. We wrap it in brackets, and then we divide that by 2. And we are going to return, let's just say out, then define out here, which is a point. And out will be, we can just have this. Actually, I could have just returned directly from like the return value. I don't need to assign a new variable. So I'm just going to say point, and a point needs dot x and dot y. So dot y will be the y sum, then dot x will be the x sum, and that looks about right. So this, the saying y sum, that's not the sum. Let's just have the y coordinate, then let's have the x coordinate. So x coordinate, and then here we have the y coordinate. Okay, so that's how we are going to find the line midpoint. So let's try print f, and we are going to say pq midpoint, right? Pq midpoint will be equals to, then we need to print the x and the y coordinates. So I'm going to have 0.4f and 0.4f, then an empty line, and then let's define not a double, it's going to be a point, pq midpoint. So this is going to be line midpoint, and then we pass a reference to pq again, and then we have to pass in pq midpoint, then we access the x coordinate, and then pq midpoint, we access the y coordinate, and that looks about right to me. Yeah, so make run, and we have an error. Oops, I passed, oh god, this is confusing. I should have passed and the ampersand. That is how you pass a reference to an object. Okay, so make run, and there we go. So the midpoint for our line is negative 1.52. That is just as we found out earlier. So we are now done with the midpoint. So the midpoint is done. Let's now talk about the gradient of a line. So how do we calculate the gradient of a line? So the gradient is always going to return a double, and then we're going to say line gradient, and it's going to take a reference to the line. And to calculate the gradient, we are basically checking the change in y over the change in x. So double, let's start with the y change. So the change in y will be we take line, we access A, and then dot y minus line, we access B, then dot y. So that is the change in y. Then the change in x, we take the same line, we access A, then this time the x, the x coordinate, and then minus the same line, let's access B, and then this time give me the x coordinate, and then in this case we are supposed to return the change in y over the change in x. So that's how you get the gradient. Let's try printf gradient of pq is equals to percent for f, yeah, since it's a double, and then we are going to get let's just pass pq gradient, pq gradient, then let's define pq gradient. So it's going to be a double pq gradient, and this is going to be equal to line gradient, and then we are going to pass in pq, and let's run this. So in our case the gradient is 1.4286. Okay, so we are now done with the gradient. Now the next thing, let's take a look at check whether two lines are parallel. So when given line A and line B, or I mean line PQ and line MN, can you tell whether those two lines are parallel? So we are going to say it's going to return an int, this new function we're defining, and we can just have, let me think, is parallel. Yeah, that's good enough. So we're going to have is parallel, and this function will take two lines. So I have reference to line, to the first line. I'm actually going to call it, yeah, let's just have line 1, and then I have another reference to line 2. So we have that, and let me think. Yeah, we are just checking if the gradients of the two lines are equal. So we need to return line gradient, and then we are just going to pass line 1, and we are checking is the line the line gradient of line 1 equals to the line gradient of line 2. So that's what we are supposed to be checking. And let's define 2 points which we know are parallel, and then some other ones which we know aren't parallel, and try checking. So I'll go back to the example we had earlier. Let me see if I can get it. Ah, nice. Great. So let's define a new line. So I'm just going to copy that here. So this new line, we are going to call it AB. So line AB will be, so it's composed of points, and the first point is 1, 4. So 1, 4, and then PQ, or rather that, wait, what? I'm supposed to be checking for point B, which is 6, 6. So point B is 6, 6. So that's that. And then now we are going to define line PQ. I'm thinking I could have done like small caps here. I don't know why we went for those. And then here we are just, let's use MN. So line AB and line MN. And then for the first point, for MN, let's use 2, -1. So we have 2, then -1. And then point B, that's 12, 3. So let's use 12, 12, 3. Okay, So now we need to check if the two of them are perpendicular. So we are just going to say, oh, not perpendicular, parallel. So we're just going to say, I'm thinking we can just do something like if is parallel, and then we pass in a reference to AB, then we pass in a reference to MN. So if they are parallel, I want you to print line AB is parallel to MN. Yeah, then add an empty line. Otherwise, I want you to print line AB is not parallel to MN. So we expect these two to be parallel to each other. So we are just going to say make run, and yes, so line AB is indeed parallel to MN. Then what if we change one of the coordinates? So if we change this -1 to maybe 1, then they are no longer parallel, I guess. Yeah, so line AB is no longer parallel to MN. So let's have the -1 back. Okay, so our function to check whether two lines are parallel is working. So we are done with that. Now, the final task is to check whether two lines are perpendicular to one another. So int, and so this function, well, basically when I return an int from a function, I'm guessing, okay, not I'm guessing, in my case it's actually just either 1 or 0, since all I'm doing inside that function is comparison, and I don't want to import or rather to use some other library just to check whether it's a boolean, right? Anyway, so again, we're saying is perpendicular, will return an int, and it's going to take two lines, line 1 and a reference to line 2. So we are saying, I want you to return, we take the line gradient of line 1, then we multiply it, sorry, we multiply it by the line gradient of line 2, and then we check whether that multiplication gives us -1. So line gradient of line 1 times gradient of line 2, and we check is it equals to -1. That is how you check whether two lines are perpendicular. And then we can start with point AB, and no, actually let's just create a new set of lines here. So let's use, let me look for another example. Okay, so I've got a set of perpendicular ones. So let's try, we are going to call this CD and EF. So for CD, point A is -1, -1. And then point B is 0, 4. Then let's talk about EF. For EF, point A is -4, 3, -4, 3, and then point B is 6, 1, 6, 1. Okay. Yeah, so that's it. Then let's check if the two are perpendicular. So we just say if perpendicular, then we pass their references. So CD, EF. So if they are perpendicular, I want you to print F line CD is perpendicular is, oh god, if I can spell this right, is perpendicular to EF, but if they are not, so otherwise, print F, line CD is not perpendicular to EF. And then, so we expect these two to be perpendicular to each other. So make run. Yep. So the two are perpendicular to each other. And if we try to change some coordinate, for example, this -1 to 1, they should now not be perpendicular. So make run. And yeah, they are no longer perpendicular to each other. So that's the end of the implementation. I hope you enjoyed this video and that you learned something. So I've checked off my to-do list. Have a great day. Yeah, have a great day.